Hello, geometry folks, and welcome to kind of the back half of Unit 6. I kind of call it Unit 6B. And this is everything and anything that has to do with trigonometry and some of the uses that come along with trigonometry. Now, in trigonometry, basically what you're doing is you're using the relationships between varying triangles. Okay, so you're going to go something like this. So if I have a right triangle, and we know that that's 90. Say that this is 32 degrees. Okay, then I have a much smaller triangle. That's a right triangle, but the angle is still 32 degrees. Okay, so if I have A, B, and C, and over here I have X, Y, and Z. Okay, so what they're saying is that because these two angles are the same, my angle relationships are going to be the same. So A over C and B over C and A over B are going to be the same relationship, okay, of X over Z, of Y over Z, and of X over Y. All I'm saying is like the relationship between the sides, even though they're both right triangles, they're of different sizes, the relationship between the sides, because these are both 32 degrees, is going to be equal. It's going to be equal. Okay, so let's talk about how we break up those sides. Okay, so trigonometry, as its word, means two things: trigon, which is triangle, and metron, which is measure. Okay, so that's kind of where this comes from, triangle, measure. So a trig ratio is a ratio of the lengths of two sides of a right triangle. So if, like right now, if you put into your calculator sine of 24, you would get 0.4067. Without knowing anything about a triangle, without knowing anything about its sides, if I've got a right triangle with 24 degrees and I take the sine of 24, that's going to be the relationship, no matter what. No matter what. Not an easy idea to wrap your minds around, but it's still something that bears thinking. Okay, so you got to realize that no matter the size variation or difference within the triangles, that relationship, that percentage, that ratio is going to be the same. So here is kind of the big concept of right triangle trig, and this is an important page. I would keep this page handy as you go through this. And the big word that I want you all to learn is SOHCAHTOA, and I'll explain kind of what those pieces mean here in a moment. SOHCAHTOA, and this is the three trig functions and what they represent. Okay, so SOHCAHTOA is, start with so. So is short for sine, okay, or sometimes in your calculator it's shortened down to sin. Often in your calculators they'll be shortened down to sin. So sine literally means is opposite over hypotenuse. So from your angle, what's the opposite side and what's the hypotenuse? So for sine of A, okay, so if I put my pencil or my pen or my Apple Pencil on A, which side is the farthest away from that angle? Well, that would be side A. Which side's my hypotenuse? My hypotenuse is always my hypotenuse, so that's going to be C. Okay? So, from angle B, from down here, what side is the farthest away from angle B? Well, side B, and my hypotenuse is always my hypotenuse. Okay? So I'm looking at my relationship. So the CA stands for cosine, and that means the adjacent side, the side touching. Okay, that's my side touching. So from cosine of A, so once again, I put my pencil on A. Which side is touching? That's not the hypotenuse. Okay, well, that's going to be side B right here. So side B over C. Okay, and then from cosine of B, so from down here, the side touching is going to be side A over C. Now, some of you may have noticed that the sine here is equal to the cosine here, that relationship. And that's not a coincidence. That ends up happening. That cosine of A and sine of B match up. Okay, that's not a coincidence. That happens. Okay, because from one perspective, from one angle, it's an opposite side, but from the other angle, it's the adjacent side. And the final one, tangent. Tangent plays by its own rules. Tangent does not have an hypotenuse involved. So you just strictly go opposite over adjacent. So that's just going to be A over B. So the tangent B is just that flipped over. So it's just going to be B over A. Okay, so no hypotenuse involved here with tangent. Okay, no hypotenuse involved with tangent. Okay, so this word, SOHCAHTOA, and you can even write it down on notes, on assignments, on quizzes, on tests, just to kind of help you keep everything straight. So means sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. So kind of keep that straight. So now as we look, okay, so now we have this triangle KLJ, and we are looking at kind of how we're going to establish that. So let's start with sine of J. So I put my pencil here on J, and sine is going to be, I'm going to write my SOHCAHTOA. So my sine is going to be opposite over adjacent. Okay, so that's not opposite over adjacent, sorry, opposite over hypotenuse. So from J, what's my opposite side? I'm hoping that you looked and saw, oh, that's 5. And my hypotenuse is going to be 13. So that's going to be 0.3846. It's usually a good idea to go 4 decimal places just because I think that it's good to keep handy. So cosine is from J, same thing. So the side that is touching it, or the side that is next to it, so that's going to be, that is just going to be 12 over 13, which is going to be 0.9230. All right, and the tangent of J, remember tangent goes opposite over adjacent. So you're going to go 5 over 12, which is going to be 0.4167. That's my answer. All right, so now I'm going to flip it around. Okay, so now I've done everything from the perspective of angle J. Now I want to look at it from K. So from K, opposite from K will be 12. My hypotenuse is 13, which is going to be 0.9230. Remember that these two are going to be the same. And likewise, the sine of J and the cosine of K are going to be the same because cosine of K, remember, adjacent over hypotenuse. So that's going to be 5 over 13. So that's just going to be 0.3846. The tangent of K ends up being just a flip of this. So now it still becomes opposite over adjacent. But now my opposite side becomes 12. My adjacent side becomes 5. So that'll strictly just be 2.4. So that's what I'm looking at. I'm looking for these ratios, these expressions to try and get it. So now if I throw in this, don't get thrown off by the square roots. That's just there. You just kind of bring them along. So sine of L. So everything's kind of happening from L here. So this one becomes my hypotenuse. And from L, this would become my opposite, and this would become my adjacent. Okay, so the sine of L would be, remember, sine is going to be opposite over hypotenuse. So SOHCAHTOA. So that's going to be 2 square root of 3 over 2 square root of 15. Okay? So now, the 2's actually can cancel out. So you could get square root of 3 over square root of 15. Now, it's not mathematically acceptable to leave a square root in the denominator. So one thing I will do quickly just is rationalize my denominator. So all I do for that is I multiply both the top and bottom by the bottom. Okay, what does that do? All right, well, that means the top, I multiply 15 and 3, and that gives me square root of 45. The bottom gets me 15. All right, so square root of 45, depending on how well you remember your simplifying skills. So that makes that 3 square root of 5 over 15. All I did was split 45 into 9 and 5. Square root of 9 is just 3. So if I really want to impress Mr. Heeren, I will simplify that down to this. Because 3 over 15 can simplify. Okay. Another way to do it would have been maybe this way. You could have put everything underneath this and simplified it to 1 over 5, and then gone square root of 1, square root of 5, and then simplified that. That would have worked as well. But either way, you'd arrive at the same answer. Okay, sorry, back to trig. So cosine of L is going to be 4 square root of 3 over 2 square root of 15. So simplified, 4 over 2 just becomes 2. Okay, I just took the 4 over 2 and simplified it to 2. And then I would go through something similar to get that. So what I would end up with is just like 2 square root of 5 over 5. So that would be my answer there. Then last but not least, tangent. Tangent would be 2 square root of 3 over 4 square root of 3, opposite over adjacent. And this is actually quite nice because the square root of 3's just cancel out. 2 over 4 just becomes 1/2. There, I'm done. Not a bad one, really. Not a bad one. Okay. This is good. Just kind of working with square roots. This is good. This is good practice. This is good review. And you should be getting comfortable with this. So now let's take a look at some of these things. So we fitness trainer sets an incline on a treadmill to 7 degrees. That's not bad. It's not bad. The walking surface is 5 feet long. So in this case, this would be my hypotenuse. Approximately how many inches did the trainer raise the end of the treadmill from the floor? Now, so this is my 7 degrees. They want this answer y. From 7 degrees, this would definitely be the opposite side. So I have opposite and hypotenuse. So if I go back to my SOHCAHTOA, I'm just, for some reason, having trouble drawing an H right now. I want sine. Okay, I want sine. Now, I have to be careful. Not because I didn't put 15, but because I put 5. So now, most students would set it up this way. And this is fine. Okay, this is fine. But remember, this is in terms of feet. My answer is asking for how many inches. Okay, so if I solve it this way, that'll give me my answer, but my answer will be in feet, and I would just have to multiply it by 12 to get inches. Okay, so that's, just be aware of that. Just be aware of that. Or another way I could do it, I could say sine of 7 equals y over 60. Now, that is in terms of inches, so my answer would be terms of inches. You could do it either way, whichever you feel comfortable with. Back to kind of algebraically, what am I doing? I'm just going to multiply it by 5. So I will take the sine of 7, multiply it by 5, and I get 0.6093 equals y. But remember, this is in terms of feet. Okay, that's in terms of feet. So I need to take 0.6093, and I need to multiply it by 12. So that becomes 7.31. So I can say this thing is about 7.31 inches off the ground. Okay, on this, doing it this way, I should get the same answer with just one fewer steps. So I take 60 times sine of 7, and I get exactly that, 7.31 inches. So wherever you have to convert it to inches, it's just a matter of where you want to do it. Okay. So here, figure out the value of x. Okay. Let's consider what we have here. So I have my SOHCAHTOA. You notice I've got these. So with our SOHCAHTOA, so let's look. So I kind of put my pencil on the 25, and I look and see what I have. So the 90-degree angle is here, which means this is my hypotenuse, which is nice to know, but it doesn't really help me for the problem. So from 25, if I go this way, this is farthest away, so that makes it my opposite. This one's touching, so that makes it my adjacent. Forgive me a moment. Let's rewrite that just so it's a little cleaner. So that's an adjacent. So I have opposite and adjacent. I'm looking for the opposite. I know the adjacent. This is my hypotenuse, but it gives me no information, so it's not helpful. Okay, so opposite and adjacent tells me I want tangent. So I would say the tangent of 25 degrees equals x over 18. So now it's a simple algebra problem. Multiply both sides by 18. That cancels out. So I let the calculator do the legwork for you. Take tangent of 25 times 18. One note, make sure your calculator is in degree mode. And if you're not sure, most calculators, or most of your phones, your iPads, you want to make sure the DEG is showing up. Otherwise, if you have another calculator, I can show you how to do that. So 18 times tangent of 25 is just going to be 8.39. And that answer should make sense. 8.39, that's a fine measurement for that. That's not too big, not too small. That's pretty fitting. So now let's look. Bottom of a handicap ramp is 15 feet from the entrance of the building. The angle of the ramp is 4.8 degrees. Okay. How high up does the ramp rise off the ground? Okay, so we're looking for this side. All right, so once again, from 4.8, I'm going to write this down again just because I want to have it handy. So from 4.8, the 15 is obviously my adjacent side. And the side I'm looking for is the opposite side. So I'm going to go tangent 4.8 equals x over 15. Okay, remember it's going to be opposite over adjacent. There's my answer. So again, to solve, I'm just going to multiply both sides by 15. So 15 times tangent of 4.8, it's going to be pretty small. So this is going to be 1.259, so call it 1.26. And realize that my answer is in terms of feet. Okay, so this is literally saying 1.26 feet up in the air over the course of 15 feet. So that's really not a bad comparison. Okay, final piece here. So let's look. So I have my SOHCAHTOA. So 15 degrees, this is my angle. This one's going to be my hypotenuse, so I have a number there. I'm probably going to use that. This is going to be the opposite side. So if I have opposite and hypotenuse, that's what I'm working with. I want my sine. So I'm going to go sine of 15 degrees equals opposite over hypotenuse. So that's all I'm going to do. Just do a little solving. So x is just going to equal 3.106. There's my answer. There's my answer. Okay, so now off you go to the quizzes and make sure you get 100%, but make sure you do the homework first. Okay. All right. Take your time, wrap your minds around this. This plays a big role in the rest of geometry.